Alright, hopefully we're live, and I'm going to continue working on the sentiment analysis project. Okay, I'm actually going to quit out here for a second. Alright, so I'm going to start a Jupyter notebook. And actually we'll just open up the EDA from the last few videos. Okay, so yeah, we had updated the way that the word tokenizer was working, and then last time we actually created a sentence tokenizer. So what I'm going to do is make this, open this again. So we'll keep the Jupyter notebook open. And then in here, activate the virtual env, and then we'll just run the tests. Okay, so our tests are passing, and so we have the ability to tokenize on sentences now as well as on words. And so what I'd like to do is build a pipeline, like just a basic pipeline where we can string together the tokenization of sentences and words and then the sentiment analyzer. So that way we'll get sentiment analysis, at least as far as we've taken it so far, on tokens that are at the sentence level. And then so we can kind of track the sentiment over the course of multiple sentences in some corpus. Alright, so I guess what I'll do is I'll go ahead and create a new test for pipelining. Calling everything simple here, mostly because it's just simple. So, by simple I mean rules-based, and we're not doing any kind of like machine learning or context-based analysis or any kind of statistical analysis on the language. All right, so let's open up our test here, and we'll create a new class. Test simple pipeline. This doesn't really need to be anything. All right, so the idea with this pipeline is we want to be able to provide some string that looks like the Gutenberg text that we downloaded. So if we just look for a book, for instance, alright, so we pull open, I don't know, yeah, let's pull open right-hand side, and if we just pull up like the raw text file here, we've got a document that's got a bunch of sentences in it. And so our tokenizer pipeline should take this text file, run the sentence tokenizer against it to get a list of sentences. For each of those, we're going to run the word tokenizer against it. And then we'll run as well the sentiment analyzer on the list of tokens in each sentence. Alright, so test simple pipeline should. So how do we want to, what do we want this thing to do? Basically, we want it to be able to implement the behavior of the sentence tokenizer. And we want it to be able to implement the behavior of the word tokenizer and the sentiment analyzer. So what's a good test that we could start with here? Well, we want to test that the simple pipeline should provide a sentence tokenizer and so we definitely want to be able to new up some pipeline, so let's just call it NLP pipeline. It's equal to a simple pipeline. And so maybe eventually our pipeline will be able to take different types of tokenizers, even within the sort of domain that our existing tokenizers exist. So like we could have a different word tokenizer or a different sentence tokenizer, for instance, in case we wanted to like tokenize non-English words or use a different method for doing that. So from there, we'll want to have our pipeline have like a run method. And then a couple different things we could do here, like we could create a mock for the sentence tokenizer, for instance, and then assert that it was called with some params. So that's interesting. Let's think about that. Also, do we want our pipeline to take a text file in as one of its constructor arguments, or do we just want to specify sort of the what features the pipeline runs? I think we could pass in the features that the pipeline runs as a list or as a dictionary, some collection, and then the pipeline will check that collection for what features we've specified and then run it against some text. So let's do it that way. So this pipeline will take in some text data. Let's just call it raw text. And it will take in some features. So our raw text can just be like foo, barbaz, and crooks. Alright, so there's our raw text. We have different kinds of punctuation and things going on in there. And then our features can be whatever we want our features to be. So let's actually rewrite this test to be a little bit higher level even, and we'll test that this simple pipeline should invoke provided features for text. Alright, so say we had some feature like bang, and we knew up this pipeline, and we could do something like get attr in the simple pipeline, get attr, and what that can do is look for an attribute named bang, like if we had a method named bang, that would get executed when we called run, along with whatever else was in features. And then we can parameterize this test so that we can experiment with features of different lengths. So then what do we want to do? We want to assert that a method called bang was called when we called the run function on the pipeline object. So this is going to be kind of interesting to do in a TDD fashion, but I'll give it a shot. So here we will basically, I think we're going to want to create a mock here. There's probably different ways to do this, but I'm going to create a mock. Wonder if I could even like mock get adder and always return some fake bang method. So let me think about this for a moment. No, I could simply assert that the method on simple pipeline, which constructs the pipeline from the list of attributes, was called. So like if we call this the system under test, then we can say that when we construct this simple pipeline with raw test and features, feels strange to want to mock this this simple pipeline now. I'm thinking about it because we mock the simple pipeline with patch. I think it's at mock.patch. And what we can do on this method here is like at patch, and we could patch simple pipeline, but we don't really want to mock. I mean, obviously, we don't want to mock the method that we're testing. We would want to mock something else. So maybe I'll be able to better understand actually how to write this test if we just play around with building an actual object first. I don't know if that's necessarily the case. In any case, we're going to have some raw text. We're going to have a feature pipeline that's going to be a list of strings that we provide to a simple pipeline object. And it's basically just going to, for each feature in features, look for attributes on itself that match. And for each of those that match, we're going to call them in the sequence that they appear in the list on raw text. And actually not just on raw text, just the first feature will be called on raw text, and then subsequent features will be called on the output from the previous feature, thus making it a pipeline. So like if I wanted to make some assertion here, what I would want to assert is that like sut.bang was called. So if we were using that patch, then it's going to end up looking like assert called once with, and then some arguments here. In this case, raw text. So let me try writing it like that, and if that's just like totally bogus, then we could write the test. I could rewrite the test differently. So here our patch will be what? Simple pipeline dot simple. So we'll put it in a pipelines namespace, like a module called pipelines. Alright, so this might get interesting. So we'll look at a failed test, no module named mock. Actually, we need to install that. And for that, I'm going to need to source the env again. Pip install mock. Alright, so mock is installed. Oops. We'll go ahead and make the module here. So this will be pipeline.py. And we'll vim back into our tests. Okay, so no module named pipelines. So actually I named that incorrectly. Yeah, so we're going to do this, and then we're going to write pipelines. Oops. Okay, so we'll run our test again. We'll just open this up in a new buffer. Ooh. Just jamming keys right now. Okay. Here we'll load up tests for test our pipeline. Okay. We'll test here. No module named pipelines, simple pipeline. Pipelines is not a package. Let me do this as well. There's everything in this directory. We do have a setup.py somewhere, right? That's interesting. We don't. So thought definitely we did that, but maybe that got deleted at some point. Alright, so it's from setup tools, import setup, and find packages. And then we just call setup. Name is simple sentiment analyzer. Version is 0.1, and packages is find packages. Okay, cool. So now we've got that. Pipelines is not a package. What happens if we don't mock first and just do something simple here? Alright, simple pipeline is not defined. So let's go ahead and define it. It'll just be an object. So from pipelines, import simple pipeline. and it takes one positional argument, but 3 were given. So let's go ahead and allow simple pipeline to take in the raw text as well as the pipeline, or like we call this features. Yeah, let's just call it features. And this was system under test. Simple pipeline has no attribute run. Okay, simple pipeline object has no attribute bang. And so this is where it becomes interesting about like how we want to test this. Like the behavior that I'm trying to test here is that given some feature, if that feature exists on simple pipeline, then we need to assert that that attribute was called. So our features list is a list of methods on simple pipeline. And if that method exists, we want to assert that it was called. If the method doesn't exist, then we probably want to write a test to assert that the method invoked in the pipeline is not available. So we could mock out this. That's why it's kind of strange here. We could mock out this simple pipeline object, give it an attribute bang for the purposes of the test, and then assert that it was called. I don't know if that's really the most appropriate way to test this, but we're going to patch this object. Okay, and then what we want to do is say that the mock pipeline, this is just setup, like mock pipeline dot bang dot return value is equal to bang or something like this. Let's see in patch if there's a way to mock patch add method to mock class. You know what I think? For now, I'm slightly overcomplicating this. Like, why can't I simply assert that like an actual real method is called? Like it should, yeah, we can do it this way. I will say that yeah, sent tokenize. So given that we want to call our sends tokenizer in the pipeline, we pass that as a list of features with just this single feature. We call this run method on the pipeline. We then want to assert that sent tokenize was called once with. text. Raw text is an argument. I wonder if there's a way besides mocking. It doesn't seem like I should be leveraging the mock library to assert that a method was called. Assert a method was called. Python. Yeah, I guess other people are using mock for this as well. So like patching an object. Test clear was called with patch object as mock. Do this mock dot assert called with. Alright, so we'll see if we can figure it out that way. So we could test that it invokes the sentence tokenizer when it's passed as a feature. It's interesting to try to do TDD with a patch because I think immediately patch is going to throw the error that sent tokenized doesn't exist. So here this is going to be like the mock sent tokenized method. So we'll just mock st and then this ct dot sent tokenize assert called once with raw text. So yeah, so now we see that the class simple pipeline does not have an attribute sent tokenize. So let's make it. Alright, so it expected to be called once, but it wasn't called because we're not wiring it up yet. So we're going to pass it this list of features. Let's write a doc string here for this. Param raw text is string raw text document containing one or more sentences. And then features is a list of strings features to run in pipe. And simple pipeline exists in order to basically allow data to flow through the different classes that we've developed to transform it. So provides a means for linking NLP classes together that transform text data. Alright, so all we want to do in run is basically for, what is it, like get adder? Something like that. Feature for feature, and you must have to pass it something else like self for feature in self.features. GetAttr object name, return the value of the named attribute of objects. So I think I had the params backwards here. So self feature for feature in self.features. Okay, so now we need a way to basically call like self.feature. So how do we Python call method on self? Python get attr and call. So we can get attr on foo, something called bar, and then splat params. This works if params is a list or tuple. The elements of params will be unpacked in order. Okay, so can we really just call so what we want to do is for feature, I don't know what that was, I spaced out for a second. For each feature, we want to call getAttr self feature with some params. And the first time that we call the params here, we actually want to just pass it raw text, I guess. So does that work? What this is going to do is it's going to take sent tokenize, which needs to take in some raw text, and tokenize it. Alt text is not defined. Oh. Cool. Alright, so we actually got a passing test now. So we're basically monkey patching this sent tokenize method so that we have some metadata about it from the interpreter. Like it keeps track of how many times it's been called and with what arguments and that kind of thing. And so now we can assert that we basically called sent tokenize on our simple pipeline object with the arguments that we expected. Okay, so we run that test again. Looks good. And so now what do we want to do? Well, now we actually want to hook up an actual instance of a sent tokenizer to our pipeline. And so we could have our pipeline we could have it sort of have like this factory behavior internally where it creates instances of the classes it needs by reading the list of features that you're providing to it. Rather than us having to do something more complex from the user perspective, or the person using the API wouldn't want to like have to new up objects and put them in a list. Rather, they just write as strings, and then we check. So for instance, sent tokenize within the method here could new up a st is a new sentence tokenizer. And maybe we call it simple sentence tokenizer, I'm not sure exactly. Tokenizers, yeah, simple sentence tokenizer. Alright, so we'll new up a simple tokenizer, simple sentence tokenizer, and then here we'll say from tokenizers import simple sentence tokenizer. st.tokenize raw text. Okay, so we also want to write a test to say that, like, if we pass it a method name for which there's no class attribute, that we throw an error. So we can assert that we raise some type of value error. So let's do that. So like, say we have something here which is like just bad. Just call this foo. Pass it the same raw text. If we try to call a simple pipeline with this set of features, which doesn't exist, here we can just mock the new object. PyTest assert raise exception. There are a few ways to do this as well. Yeah, with PyTest.raises looks like the cleanest. So I could say with PyTest.raises. Then do we pass that? Yeah, so we can pass that I think that's value error. Okay, so here we'll import PyTest. Oops. ct.run. Failed to not raise value error. So we need to make sure that our class raises a value error when it finds a class attribute or gets past a class attribute that doesn't exist. And what we'll say is try this, and we'll accept raise value error. No, sorry, what am I doing? I'm too tired. Let me accept value error as E. For now, let's just print E. Not raise value error. What happens? We'll just do accept exception as E. So actually in this case, why does this work? Feature in self.features, try, except, do we want to like finally continue? Oh, no. Feature in the features available, we're going to try to get the attribute and call it using the raw text class attribute. In fact, if we pass it as part of the features, any invalid feature in the pipeline, we probably just want to throw an exception right away, rather than, yeah. So let's go ahead and try here. Like, what happens if I just take this out and we call get attribute on a feature which doesn't exist? Why does that pass? Oh, because it's a mock. I'm an idiot. No, still we're getting this test to pass when it definitely should not pass. We knew up a simple pipeline. Oh, because we're not calling run as well. Man, I am so out of it. Alright, attribute error. It's not even a value error. I am like not with it this evening. So we're gonna go ahead and try here, accept attribute error as E, print no feature named simple pipeline supports no feature named. Format the feature that we tried here. Okay. So now we can run and we catch the exception, but we really want to say with PyTest raises attribute error, and we obviously don't need a mock here. Okay, sweet. So now we assert that we raise an attribute error when we pass the simple pipeline some feature that doesn't exist. And what I'm also going to do here is parameterize this for a few different cases. PyTest.mark.parameterize input expected and actually in this case we just need to test a few different inputs. So like given the first use case where we just have foo, given the case where we have an input foo and then something which does exist like sent tokenize, input not found. Because this needs to be like that. Make sure input not found. We're gonna try this. Okay, cool. So we have a couple of use cases there. We can probably clean this up a little bit. We've got our list of tuples. And let's do one more use case. Where we have two legal methods. Okay, cool. So we got 30 passing tests for the entire suite so far. Add pipeline tests for a run method. Alright, sweet. So now if we go back to our pipeline, when tokenize gets called, when sent tokenize gets called here, we new up a simple sentence tokenizer and then simply call its tokenize method. That's the output. So essentially we want to return this from sent tokenize. Invokes the tokenize method on sentence tokenizer. One thing I'd like to look at is the sklearn library that has classes of methods that are like transformers and what's the other one? Anyway, basically you can build pipelines in sklearn that do something similar, except that all of the methods are very uniform, all the classes are very uniform, I should say, and so for instance, regardless of whatever type of transformer it is, all of the transformers have a single method transform, and so I would want to do something perhaps similar here, where all of the tokenizers have a method tokenize, or maybe even just a method execute, or something, so that we could kind of duck type subclasses. Anyway, that's probably getting way ahead. So here we want to also invoke the tokenize method on the word tokenizer. On simple word tokenizer on simple sentence tokenizer. So one way I can already see that we would want to refactor this is to kind of inject the specific tokenizer that we'd want in each of these methods. Like the behavior of the pipeline should not be to explicitly call a particular class's tokenize method, but we should be able to sort of compose the pipeline of tokenizers that we want. So if I had like 3 different sentence tokenizers built, I would want simply to invoke the instance of the sentence tokenizer class. And so maybe eventually we build some way to sort of do some type of inversion of control, perhaps, where like simple pipeline can just ask for the particular types, like the actual types of tokenizers that it needs, and then we would simply just have like self dot sentence tokenizer tokenize raw text. In fact, if we wanted to restructure this so that we had, well, no, I wouldn't want to do that. I don't think that right now we'd want to move instantiating the tokenizer classes to the initializer of simple pipeline, because you don't want to know up a class that you're not going to use, and you're not going to use something if it's not part of the features. So for now, I think that this is okay. So here we have the simple word tokenizer. Actually, I think we just called this one simple tokenizer. Input, and we want to call it input here as well. Okay, so we're still passing tests. Here what I'm going to do is actually, I wonder if I can have the parameterized decorator on top of the patch decorator. So like we want to test, actually I'm just going to make it a separate test for right now, and I can refactor the test later if we want. So simple tokenize, word tokenize, and should invoke the word tokenizer, and so given some input text, we can call it raw text again, features word tokenize. Then we new up a simple pipeline with the single feature word tokenize. Okay, so we get that to pass. Now we can actually test that I wonder if we can test the order in which things were called, because that's going to be important, obviously. So that'll be important behavior for the pipeline. So we can test that the simple pipeline should invoke features in order. So we can patch word tokenize and sent tokenize, and here mock. Not actually using the mock object in the test, we're simply using the fact that patch monkey patch is that method so that we can catch it and examine whether or not it was called and with what arguments. Alright, so we got our mock sent tokenizer, and here we've got our mock word tokenizer. So we want to assert that word tokenize was called once with raw text. And what we can do here is thanks, Miguel. Yeah, thanks for watching, and I'm glad that you're liking the channel. I really appreciate your support. So here, what I want to do is make a return value for mock sent tokenize. So we can say return value is equal to like foo, and we can also say word tokenized.return value. We don't want to test the behavior of the tokenizers. That's handled in the tokenizer test. We want to test the behavior of the pipeline. But the pipeline's behavior is to pass the output of the mock sentence tokenizer to the word tokenizer. So that's why I need to establish that the return value will be something that we can control here. So I don't want to just like manually guess at what the sentence tokenizer is going to do to our raw text here, because that should be tested elsewhere. So like we can assert that word tokenize was called once with raw text, and we can assert that actually sent tokenize, and assert that word tokenize was called once with foo. We haven't built this behavior yet, so we should get a failure. So let's think about this for a second. This isn't really testing that they get called in order yet. This should invoke all features. Yeah, actually it does, because foo only comes from the return value of mock sentence tokenizer. And so if we were to place this assertion first, then we would get a failure because that wouldn't be the order that it was called in. So let's see what kind of failure we get here. Expected sent tokenized to be called once, called 0 times. It's because we need to include sent tokenized, word tokenized in our list of features. So expected call word tokenize foo, actually word tokenize and then the raw text, and that's because of the way that we've so far constructed the run method is just for feature and features, and we're calling getAttr. So what I want to do is say like the result is getAttr, and then let's see here. First thing we can do is like this. We'll say try result is first self.raw text, and then here actually that's not going to work. Let's think about this for a second. So if we run this test, actually, yeah, that works because the result hasn't been set yet. Nice. So we've got a test for creating a basic pipeline here. So the way that this works is no matter what we do, no matter how we construct the pipeline, it's going to pass raw text to the first argument. And so I think for all of these, I should really just call it input text. So here we have param input text, string text to tokenize, same here. And then finally, we should also have the ability to score sentiment. So invoke the score method on simple sentiment analyzer. And I should have done this in a TDD fashion, so in fact, it will, just to be clean here. So we'll write another test. Where we test the simple pipeline should come back up to the feature tests. So test simple pipeline should invoke score sentiment. Good stuff. Simple tokenize, raw text, features, and we're going to assert that here we have our mock score sentiment. Assert called once with raw text. And I think that everywhere here in this, I actually want to call raw text input text. Okay, so let's go ahead and run this test. And the simple pipeline does not have the attribute score sentiment, so we'll go ahead and make it. Invokes the score method on the simple sentiment analyzer. Okay, param input text is the same, but it's the string to score sentiment. Simple sentiment analyzer, and then we'll return sa.score input text. Here we need to input text, and then likewise I think I'm going to make raw text input text everywhere, except in the input text here at the very beginning. We're going to call this raw text for sure. And then for the docstring on run is basically to execute the transformation methods on attributes in the pipeline. From sentiment analyzer, import simple sentiment analyzer. Sweet, so we have the pipeline invoking the sentiment score. And now we can hook all three up and assert that they are called in a particular order. Parameterizing this test is an option. It just starts to get kind of ugly with all the decorators and not so readable. So in that case, I can just write additional unit tests rather than parameterize everything. So like we could test simple pipeline should invoke 2 features in order, and we could do another one here where it should invoke 3 features in order. And really I don't care too much about like not necessarily having fewer tests written with more cruft up here, like on a decorator that to parameterize that test, so it does not really matter. So if we want to test that it does 3 features in order, explicitly we can do that. And so here we'll say score sentiment box score sentiment, and we'll just this one up. And we can say mock word tokenizer, return value, doesn't matter what it is. 234. So then we can assert that the sentence tokenizer was called with the input text, word tokenizer was called with foo, and the score sentiment was called once with 1, 2, 3, 4. Alright, sweet. So if we run all of our tests in the entire app now, we've got 34 passing tests. We've got a basic pipeline class that has a run method, and its only behavior is to pull together a list of features that it gets passed and apply them in order to raw text. Hey Zach, yes, I do have a full-time developer job, and I do basically work in search. So yeah, I work in search, do sort of like microservices based architecture with Docker and Python, and I work with a bunch of different databases, and yeah, it's fun, it's good full-time work. And yeah, thank you. Thanks for watching. Okay, so yeah, so we've got decent test coverage on the pipeline module now. And so maybe in the next stream, what we can think about is hooking this pipeline up to work on literary text, and maybe on like longer reviews, like the Reddit reviews, or Reddit comments that we saw last time. So I'm pretty tired right now, so I think I'm going to take a little break. But yeah, I'll go ahead and commit this up to GitHub. Oops. Pipelines, coverage, add score set. Cool. So yeah, that'll do it for tonight, and I'll catch you guys next time.